Hey everyone, thanks again for joining me here today in today's session. This is Powering Your APIs with Kong and AWS Lambda. My name is Chris Munns, and I am a Senior Manager and Lead of Developer Advocacy for Serverless Technologies at AWS. And I'd like to thank the folks at Kong for inviting me to speak here today. I'm hoping that you'll find this session useful in helping to ramp up your knowledge on Lambda, how I think it's the best backend for your APIs. Again, a little bit more about me. So currently, I, again, lead developer advocacy at AWS. I've been at AWS for a little over 8 years across a couple different roles. And my team is responsible for building a lot of the content that you see out there, whether it be on the AWS Compute blog or on Twitch or YouTube or other places. And I'll have some links at the end for where you can find some more content from us. I'm based outside the New York City area and have been here for most of my life. So why are we here today? We're just about approaching the 6-year mark since we first announced AWS Lambda back in 2014 at AWS. And in that time, we've seen it really be a transformational technology across the industry. Yes, it has led to this buzzword of serverless, and we see that abused a whole lot. I'm going to try not to talk about that buzzword here too much today, but I do want you to understand what Lambda is, where it is today in 2020, what some of the biggest changes have been over the last couple of years, and again, how you can jump right into using it for powering APIs specifically. So again, we're going to be focusing pretty much on Lambda today. For those of you, again, who are not familiar with Lambda, it is a compute service. And Lambda is a pretty powerful technology. And again, now that it's been in preview and then GA and available now for about 6 years, at AWS, that makes it a pretty mature, well-rounded product. And so you'll see some of that here today. I wanted to highlight some of those capabilities and some of the things that you may not be aware about so you have further understanding. Now, sometimes people confuse Lambda with just a server. They think of it as just a virtual machine, just a single host or something like that, or even maybe just like a container orchestration service. It's really a lot more than that. Lambda handles a whole lot for you. It's basically a complete stack in a service, if you will, to a degree. And so Lambda obviously is going to run and execute your code, but it's doing that based upon a full stack of things. That includes load balancing, it includes auto scaling, it includes all sorts of system and network management that's happening behind the scenes, all sorts of various layers of security and isolation. And again, a ton of things that if you were managing it yourself, this would be a lot of work, especially at scale. Now, when we talk about this concept of a serverless application, we're typically referring to an application where Lambda is the center of it. There are ways to do serverless applications without Lambda, using some of the other services that we have here at AWS. But for today's talk, I'm going to be focusing about it with this Lambda-centric model. And so with Lambda, what you do is you decompose your application down into smaller chunks, which we would call a function. Today in Lambda, we support a number of different languages that we have as managed runtimes. Those are the first 6 that you see here. So Java, Node.js, Go, Ruby, .NET, and Python. And then we also have a capability called the Runtime API. And so what the Runtime API allows you to do is bring almost any language that you want to Lambda. Base requirements are that it has to be able to run on Amazon Linux, which is our Linux distribution. And then outside of that, that's basically it. So we've seen customers bringing Erlang, bringing PHP, bringing COBOL, bringing so many different things that they've run in other environments. And you can run those inside of Lambda with the Runtime API. Now, so that's your function. That's the code that you've written. What you then need is something that will go and invoke that function, or essentially cause that code to execute. So you need some sort of an event source. Today at AWS, there's over 100 different event sources that can directly or indirectly invoke a Lambda function via one of, say, our messaging services or event routing services. And so this, again, is everything from your Kong API gateway to Amazon S3, to IoT devices, you name it. There's a lot of different ways that you can invoke Lambda. And so something happens, change data, request an endpoint, that goes to that service, and that service then is going to invoke the Lambda function. We'll talk more about how that happens here in a moment. And then again, what your function does is up to you. So it can talk to databases or data stores, relational, non-relational, API endpoints that are out on the internet, API endpoints that are privately in the internet. or probably in your infrastructure. Almost anything that you could do anywhere else in a normal server, you could do in Lambda. Again, without you having to manage it. You don't manage any of the scaling, any of the underlying infrastructure, no OSs, no container orchestration, none of that. So when it comes to the anatomy of a Lambda function, there's basically one really big core concept, which is the handler function. This is the entry point for your code to be executed. So when we get an event, what we look for is, okay, now we need to execute the code that exists inside of the handler function. What comes into that then are two things. The first is the event object. Pretty straightforward. This contains the data from your event source. So in the case of an API request that comes over HTTP, to include all of the headers and cookies and related bits that would come in from that HTTP request. And in the case of, say, something from Amazon S3, it would be the bucket name, the object, and then the action that happened on that object. Similarly, if we were processing data from a queue, it would be potentially just the messages that have been pulled out in a batch. And so that event data is what you're going to process and do whatever it is that your business logic needs to execute upon. And then lastly, we have the context object. And so the context object, a little bit different here. This is something that is built by the Lambda platform at invoke time. It contains a bunch of information about your function, about its configuration, and then you could interact with that inside of your code for various different means. You could track logging information, you could track the amount of memory that you have and you're using and consuming. So there's a bunch of places where that could become useful. Now, again, a lot of you probably are aware of Lambda, but for those of you who don't, one of the key aspects to Lambda is its billing model. So with Lambda today, we bill you in 100 millisecond increments for the duration of your function execution times the amount of memory that you have configured for it. So that becomes a multiple factor on it. So more memory equals more cost, again, in alignment with how long your functions might execute. But this 100 milliseconds is the smallest, most granular billing in the industry when it comes to execution. And so given that we're charging on a per request basis, this means that you can have very tightly aligned costs to your business. And so this really changes the game for a lot of our customers when it comes to building APIs. And again, the whole model behind serverless is that when you're not using it, you're not paying for it. So if you have an application that's strictly 9 to 5, you can expect that you're only going to pay for the requests that come in from 9 to 5. No hourly commitments, no daily, anything like that. We'll talk a little bit here about this little asterisk by never pay for idle here though in a moment. So one thing that we announced at the end of 2019 is a concept called provision concurrency. And what provision concurrency does is it allows you to essentially pre-create the Lambda worker infrastructure that your code is going to execute upon. Now this becomes important because since Lambda is an event-driven system and it responds to events, that would mean that it would scale and launch resources or align resources to your function at execution time. Now the time that it takes for that new resource to download your code and start up the runtime environment and execute what's called pre-handler code is effectively referred to as a cold start. And it's typically been one area of frustration for our customers since we first launched Lambda. So what provision concurrency does is it basically just solves this for you. It will go and effectively pre-warm that infrastructure, and then it basically greatly reduces any sort of cold start impact that you might see. And so you see here from this chart, the orange is the infrastructure that's been launched with provision concurrency, or I should say the functions that have been configured for it. And so you see the much lower increase, or I should say variation in latency out at the P98 and above on this chart. So basically, again, what you do is you flag this on and it pre-warms those environments for you, and that's about it. It has a slightly different cost model because of it. However, if you end up highly utilizing your provision concurrency capacity pool, then you end up saving money on Lambda. So it become one way for customers who have regular traffic, heavily utilized request patterns, that you can actually save money on Lambda. It's also implemented with auto-scaling. So you can enable auto-scaling with provision concurrency and be able to really tightly track that throughout the latency and usage of your functions on a given period of time. Now, I talked before about how we have this invoke pattern and event sources can invoke Lambda. The way that is done is via the Lambda API. So AWS, pretty much everything we have here is driven by APIs. It's kind of the way that we've always been since we first started AWS all the way back in 2006. And so with Lambda, much like, again, most of our services, you call to an API and then that causes the Lambda function to actually execute your code, process the event, and do whatever it is that your business logic needs to do. There is no other way to talk to a Lambda function directly. You can't reach out to it on a port or a socket. You don't have anything like that. The function exists entirely just behind this API. And so anything that talks to Lambda to invoke a function has to come from this API. Includes AWS services, includes things like Kong API Gateway, or other applications that you might write that might consume our SDK. And you can build your own. So you can use the AWS SDK to directly integrate with Lambda and build your own event sources. So what this gives us is 3 different ways that you can invoke Lambda. There is the synchronous model, which is really common in API-based workflows or interactive workflows, where you make a request to an endpoint, such as your Kong gateway. You want that then to invoke your code on the back end to execute that call. That function returns a response back up to the Kong gateway, which replies up to the client. It's the synchronous motion. In the asynchronous path, what we have are services like Amazon S3 and Amazon SNS and a number of services where they are going to receive a message or receive an object or receive an event. They will then go and invoke Lambda on your behalf. But because there's no path back up to the original client, this is just an asynchronous motion. So your Lambda function would process the event that it received, do whatever the business logic was that it needs to do, and then onward. And then lastly, we have a model around stream or pull-based workflows. Today, we support this with Amazon DynamoDB, Amazon Kinesis, and Amazon SQS, or our Q service. And in this case, what we do on the Lambda side is we actually run a poller, which polls or watches those streams looking for data, and then goes and invokes Lambda on your behalf. And again, we completely manage that poller so that you don't have to do that type of a thing yourself. So this means that you could build these, very, very low administrative overhead, high throughput, high event volume type systems, again, without having to manage any infrastructure yourself. So putting all this together, where we see Lambda, it's in a ton of different places, obviously in APIs, empowering things like mobile applications and internal backend microservices at companies. But we also see it driving things like chatbots. We see it driving things like data processing, batch processing, ETL workflows, real-time streaming data processing, and then as well as things like responding to events inside of your infrastructure. This could be development tools, management tools, security tools, any of these things where we see some sort of an event come in that will then need to be consumed or acted upon. So Lambda works really well for that. So when it comes to the permissioning model, or kind of the core concepts of security for Lambda, there's basically 2 key things that you need to know. One is, again, on the networking side, you can only access Lambda via its API. The second is that we have 2 different IAM policies that are really important or key to know about when it comes to talking about security of Lambda. And that's identity access and management, I should say. So the first is the function policy. This is essentially the policy that states who can invoke this function? How can they invoke this function? Can it be done for other accounts, for example? And so this is something that you have to create. We'll talk about this in a little bit when we talk about how to integrate Kong API Gateway and Lambda, that again can allow other services to be able to call and invoke your Lambda function to the API. The second is the execution role. And this is basically something that is assigned to the Lambda function itself that your code can use the rights of to talk to other AWS services. So these are things like, can my function talk to this database? Can my function call this other AWS service? And again, this is critical so that your function is properly scoped to only be able to talk to what it needs to. Again, 2 key aspects here that you'll end up spending quite a bit of time on when you start working with Lambda. I want to touch really briefly here on storage in Lambda, and then we'll talk about storage that can be attached to Lambda. So with storage in Lambda today, there are 3 options that are built into the actual Lambda function execution environment that your code runs in. The first is obviously the memory configured for your function. And so today we support everything from 128 up to 3 gigabytes. And that can be used however you need to. You could store stuff in RAM. Your application code is obviously going to consume RAM. So whatever you might need to do with that space local to the environment. You also have temp space, so 512 megabytes of temp space that are available to you for whatever needs you might have. And then lastly, there is the application artifact space. So between your actual code and if you potentially use Lambda layers, which is a technique to allow you to have reusable code components, today with that, you get 250 megabytes of uncompressed data available to the worker. So all these are places that you can store data, information, training models, et cetera, local to the actual execution environment. We also give you two options for being able to talk to storage that live outside of your Lambda function. So S3, which is basically the first service that we built Lambda for to be able to process events from. You could also have your code be able to push and pull objects in and out of S3 for all sorts of reasons, to download, again, things like machine learning models, to download dependency code that you might have. Lots of reasons you might need to do that. And then a couple months ago, we announced integration with Amazon EFS, or Elastic File Systems. What this allows you to do is have a NFS mount to your Lambda function, such that you can access this much, much larger, potentially terabytes of information that could exist inside of an EFS volume. And this can be shared across many Lambda functions. It can also be shared across other compute options at AWS. And so this gives you another flexible way as a file system for being able to put data in and out of your Lambda function environments. So touching back here on networking real quick, again, there are servers behind serverless. And so when it comes to the Lambda function environment and how what resources it has available to itself, by default, it has full access to everything out on the public internet. That means both in AWS's infrastructure and outside of that. So you could talk to any HTTP endpoint on the internet. You could talk to any AWS service that has an API on the internet. You could talk to any host that has a port or a socket that's available out somewhere on the internet. By default, you don't have any way, though, to control this networking. So you can't, for example, control egress of these functions. You can't cause certain routing or change the DNS hosts of these, of the underlying environment. But again, this is the default way that most people have Lambda executing if they just need to talk to public resources. Now, if you need to talk to private resources, there is also a way for you to do what's called attaching a Lambda function to a VPC. So a VPC, or virtual private cloud, gives you the ability to basically create your own private data center inside of our cloud, as it were, that you can do things like create subnets and route tables and network ACLs, and really be able to carve up a networking infrastructure inside of the cloud. You have the ability to do what's called attaching Lambda to that. And what this means is that we actually create a VPC to VPC NAT device on your behalf that gives the function access to talk inbound to your VPC. So if you have relational databases or caches or other services or APIs that are running inside of your VPC, Lambda can talk to them via that virtual NAT device. It behaves as any virtual NAT well, so it is only really meant from the function into the VPC. So that's the direction that it NATs traffic. You can't still talk directly to the Lambda infrastructure underlying of that. It also doesn't change anything about how your function is invoked. So your function still has to be invoked via the Lambda API. So that's an important thing to note. But again, one key capability of Lambda today. So one thing I want to touch on again, real quick here is one of, I think, the most core aspects to performance related to Lambda and serverless applications. With Lambda, we pretty much just present out to you a single knob, which is the ability for you to turn up the amount of memory that your Lambda function has. And with that comes a proportional amount of CPU and networking throughput that you get. So as I go from 124 to 256, or actually 128 to 256, I'm essentially doubling the amount of, again, networking and CPU power that my function has. Now, one way to actually think about visualizing this, and this is obviously a really canned example of a very CPU intensive workload, but what I find is that often a lot of customers don't realize where they are CPU bound or where they might be networking throughput bound. For example, today, many APIs out on the internet or inside of your infrastructure use a much higher bit rate SSL certificate than they would have in the past. And it actually requires more CPU power to handle those SSL secured conversations, or TLS as it were. So here in this example where we have basically calculated 1,000 times all prime numbers less than 10 million, I believe this is here, or a million. What you see across 4 different memory configurations is how it starts at the slowest and then gets fastest. And then we see that the cost kind of jumps around here in the middle. So the cost is definitely the lowest at the 128 megabyte configuration, and it's definitely the fastest at the 1024. But if we look at the differences between the two, it's basically shaving off 10.5 seconds for 0.0001 of a dollar. And so again, you can see how that might be a worthwhile trade-off to you. That might be something that makes sense for you to, depending on the performance requirements of your application and your business, to crank up that memory knob, get more CPU power, and potentially pay a small bit. However, we often see that customers regularly save money by doing this. So your function will execute faster, you'll have a lower duration cost, and so you can save money by turning up the memory configuration. So how can you measure all of this? So built into Lambda, as well as many of our services here at AWS, are a couple of different options that you have. The first is CloudWatch logs and metrics. So with metrics, we've got a number of metrics that are built directly into Lambda. These are some of the most common. I think actually this number is now technically out of date. I think we're at like 9 or so. But things like the invocation count, error rates, those are really common basic metrics that you'd want to track. You can also, from inside of your code, create custom metrics either via the Lambda API put metric data call or via something called the embedded log format, which you can read about on the CloudWatch documentation. From a logging standpoint, we capture a number of things that the Lambda platform puts out there for you, as well as also, again, make it easy for you to be able to just create logs. So whatever language you are running, the equivalent of a console.log or a printf statement gets captured by the underlying work environment and then forward onto CloudWatch logs. So you don't have to worry about writing a logging daemon or configuring any sort of code on your side to make that happen. It's just built in. And then what you do with that data is up to you. You could process it there in CloudWatch. You could send it off to an Elk Stack. You could send it off to Splunk. You could send it off to S3 to be processed later on. Again, that data is just easy to pull out and capture. Another tool that we have in this space, which is an optional one, is AWS X-Ray. And so with AWS X-Ray, you have the ability to basically configure a way to capture trace information through a distributed system. It's really easy to turn on with Lambda, basically a checkbox, and then you can include the optional SDK to gather even more information. It gives you this nice service map here. Also gives you access to a waterfall diagram, so we can see here how much time was spent in this application doing various things, and also capture bits of latency data and so forth, as well as error information. Then you also get access to something called X-Ray Analytics, which can provide kind of a longer term trending of the performance of an application, allow you to understand where in the performance charts you have issues, what does your P95 look like, or P99 or P99.9, and be able to understand what the latency impact is for your services. So that covers Lambda. What I now want to spend a couple of minutes on here is talking about how Lambda and Kong work together. Unfortunately for me, there's not a whole lot to say because it's so straightforward. And the Kong plugin today for Lambda is really powerful. And again, it's something that you can pretty much just turn on and it works really well. But I do want to cover some of the nuances of it here and help you understand, again, some of these bits that might be different depending if you are not familiar with Lambda or you're maybe not as familiar with Kong. So again, with Kong Gateway, you can directly interface with Lambda. You get all the powers that you had with Kong, you get all the capabilities and powers that you have with Lambda as a service. And this is part of the pluggable nature of both of these. They're meant to be worked with and plugged into different backends or have different event sources in front of them. You're accessing Lambda the same way as every other event source would via its API. So you're talking to the Lambda API with this plugin. And so again, it's not any worse, not any better, not any different than anything else would be talking or trying to invoke a Lambda function. Now, there are some basic things that you will need. The first is that you will need IAM permissions to invoke your Lambda functions. This means that you have to have the appropriate IAM policy or EC2 role assigned to your Kong infrastructure, or you're going to need the secret key and access ID credentials that are created by an AWS user in IAM. Your Kong infrastructure will need access to the Lambda API. So if it's inside of a VPC, it's going to need to talk out through a NAT gateway or via public IP addresses somehow. So you will need a way to route to that public API today. And then the way that you configure Lambda is at a couple different levels, either at the service, the route, the consumer, or at the global level. This is just a quick snippet of showing Lambda being configured with a route. Again, here, the AWS key and the AWS secret are optional if you're using an EC2 role. The plugin will actually just pull that out of the underlying EC2 metadata for you, which is awesome, makes it so easy. Or if you have to configure these credentials in here, you can. You can define the region, and then you use the function name, and then you have the ability to configure the timeout and keep alive, which are just standard plugin configuration options. On the IAM policy side, again, what you need to do is basically have an action that is Lambda invoke function. You want to allow that, and then you do want to tie this back to a specific resource. It is key that you are tying, you're locking down your infrastructure so that you don't just give this an asterisk and allow it to access anything. That's a poor security practice in our world. Okay, again, a couple of tips here. One cool thing that you can do is enable the correlation ID plugin in Kong. That will create a correlation ID, which can then be passed down to backend resources via headers. You can then capture that in your Lambda function and then put it into AWS X-Ray either as an annotation or metadata that gets passed on. So you can effectively glue the two together and get all of the benefits of X-Ray and CloudWatch, or pass this on to any other tool that you might be using for this. You want to make sure that your Lambda function timeout is less than your integration timeout. And this is such that you are able to capture and handle any failures from Lambda that might occur, versus there being the instance where your Lambda is continuing to execute after your backend is timed out. And this will just make troubleshooting much, much easier. Again, you want to lock down your Kong instances to specific Lambda functions, general security practice. And then you can finally remember that more memory equals more performance. And that's the basic, most easy troubleshooting thing that you can do. So in closing, we've covered a whole bunch here really quickly about Lambda, about its capabilities. Again, the benefits of this serverless model that we have here of AWS for paying for just what you use, built-in high availability, built-in scalability, really key, critical for a lot of the APIs that you're building. Super easy to integrate with Kong. I wish I could have spent the whole talk talking about it, but it's just so easy to configure and point that, again, it should be really easy for you to explore, configure a couple of routes, try it out, do performance comparisons, and so forth. And then lastly, with the capabilities that we have here in Lambda today, you have the option and the ability to build really any kind of API backend that you need, public or private, talking to services that are public on the internet or private on the inside of your VPC. All of those types of things are available to you. We've got a couple places where you can go and find out more information. The first is aws.amazon.com/serverless. This is our primary landing page for all things serverless today. We also recently just launched a site that is called Serverless Land. So you can find this at serverlessland.com. This includes blog posts, videos, learning paths and tutorials, upcoming events that are focused on serverless technologies. And this is something that my team recently just put together. As far as questions go, I've been trying to join in here and answer them via text. However, if you have any questions outstanding and you'd like to reach out to me, you could find me at munz@amazon.com or at Chris Munz on Twitter. Again, thank you for joining me here today in this session. Hope that you've had a chance to learn a lot. I realize we've covered a whole lot, so please do check out the resources that I mentioned or reach out, and I'm always happy to help you however I can. Thanks. Enjoy the rest of the summit.